1 over T1, and maybe your second set is P2 V2 over T2. Okay, how about the last law that you have learned? What do we call it? Ada
Ideal
satu law
gas
lagi
law.
kan? Okay, ideal gas law. Seperti nama dia lah, ini adalah equation ideal gas law, the law for our ideal gas. So we will talk a little bit later. What is it about the ideal gas law? Maybe in our next lesson. Today is just mainly calculation. Okay, but remember that our ideal gas law, we have a formula PV equals to nRT, whereby pressure, we have the unit in, let me change a little bit color, pressure in ATM. Oh, it's already here. Okay, pressure in ATM. Okay, volume in liter, or sometimes it will use the MQ. Okay, liter or dmq, both are the same. And then we have our number of mole. Okay, and then we have our gas constant. This gas constant must remember the values 0.08206, and then the unit is ATM, liter per mole per Kelvin. Okay, and then the last one, what does it stand for? What is the T stand for?
Temperature.
Temperature.
Temperature, and the units must be in
Kelvin.
Kelvin. So if you still
Kelvin.
remember our temperature, if let's say I have 20 degrees Celsius. So in order to change into Kelvin, we must 8273.15. Okay, so in this case, we have 293.15 Kelvin. So this is how you convert into Kelvin. Madam will check with you in another slide when we talk about the unit conversion. Okay, so now we want to try a little bit of derivations of formula. Okay, so have you tried these two column? Dah cuba belum? Nak masukkan mole formula dan density formula dalam PVNRT. Have you tried that one? Yes, no, yes. Okay, untuk siapa yang sudah cuba, awak boleh check ya. Yang tak cuba, tolong tuliskan dan completekan dalam tempat kosong sini. Okay, so we want to rearrange the ideal gas equation using the formula of mole equals to mass over molar mass. Okay, so substitute N into PVNRT. You can see over here, yeah, PVNRT. Okay, so let's just do this. PV equals to nRT, and since N equals to M over molar mass, so we just substitute only. So mRT over mR. Okay, so that means you substitute this thing into the N here. Okay, and then the next one asks you to make the molecular mass as the subject. When it asks to make a subject, you just simply rearrange. So we want the molar mass as our subject. So put it on the left-hand side, and then you just try to rearrange mRT over PV. So here you go. You have a ideal gas equation which include the mass and the molar mass. Is that okay?
Yes, madam.
All right. So the next one, rearrange the ideal gas equation using density. So the density over here, we have D equals to mass over volume. Okay, sometimes the density, we will use the symbol rho. Both are the same. Either you're using D, okay, or you're using the rho symbol to represent the density. Okay, so now substitute the density into the formula that containing molar mass. So that means we want to use the one we just rearranged. Okay, and then we want to substitute this D into the formula here. Okay, so in the formula with molar mass, can you see M over V? Did you see M over V? Nampak tak M over V dalam formula dekat sini? Ada kan? Kita ada M, ada V. Okay, so now we try to rearrange a little bit. Molar mass equals to M over V, and then we have RT over P. Okay, so whenever you see here, we have already got our density, isn't it? So we just substitute the symbol of D into your formula. Okay, so equals to dRT over P. Okay, gas constant, temperature over pressure. So until here, can everyone follow?
Yes, madam. So we actually
Yes.
You just
kita
play
pisahkanlah
around.
MV tu dulu
Yeah,
kiranya.
betul. So
Okay.
this one is just the technique on how you rearrange your formula. You just play around with the formula. So which one you want to make it the subject, or the king? The subject is the king, so you try to rearrange it. Okay. So now the another things here say that you want to make the density as the subject. So now we try to rearrange. Okay. So make D the subject, and then we just bring over the pressure. Okay, and then times with the molar mass, and then over our RT. Okay, so make the density your subject. So you bring over pressure to the molecular mass size, that's the other side lah, and then RT to another side also. Okay, so until this part, is everyone okay?
Okay, madam.
Right. So maybe you will ask, Madam, is it necessary for us to memorize both of this formula? Maybe yes, if you can memorize, but what is more important is you need to know what is the steps to do this rearrangement of formula. Nak susun balik senang saja kan? Sebab awak sudah ingat mole equals to mass over molar mass. You have already know density equals to mass over volume. So you try to rearrange very fast one. Okay? Tapi nak hafal tak ada masalah. Cuba madam cadangkan untuk awak ingat yang paling penting PV and RT, and then mole equals to mass over molar mass, and then density formula. Okay. So it's not necessary for you to memorize. You can always do your derivations on your own. Okay. So, kenapa kita nak belajar derivation ini? Sebab ada soalan juga dia akan tanya density. So, when it's asking for density, that means we will use the formula over here. Now, D equals to P mR over RT. Ataupun kalau soalan minta molar mass, awak kena guna formula ini. Boleh pakai formula ini. Ataupun awak pisahkan, carikan PV and RT dulu, baru guna N equals to MR. Okay, so we'll see the questions later on, yeah? Okay, so the next one we want to see and I want to check is the unit conversion. Very important. Okay, very important. Yeah, so over here you can see 1 ATM, okay, is equivalent to 760 millimeter mercury. mmHg, Hg is the symbol for mercury, yeah? Okay, so millimeter mercury. 760. So this is a fixed values already. Okay, at the same time, 1 ATM equals to 760 torr. Okay, or it can equivalent to 101325 Pascal. Now, PA stand for Pascal. And then KPA stand for kilopascal. So perbezaan dia cuma decimal point saja untuk kedua-dua ni. Okay, and then if you see the unit for Newton per meter square, or Nm negative 2 Newton per meter square. Okay, so over here you still got the same value as Pascal. So if let's say you got kilo Nm negative 2, so the value is the same. You just divide by 1,000. So from Pascal into kilopascal for Nm negative 2 to Knm negative 2. So value dia lebih is the same. But you have to take note, you have to check the unit always. So let's just try the pressure. So this one stands for your pressure, yeah? Okay, kita cuba. Okay, now if I give you a value of 740 tol, okay, how am I going to convert into ATM? Macam mana nak convertkan dia kepada ATM? Anyone have an idea?
740 divided by 760 turn per ATM.
Okay, 740 divided by
760 turn per ATM.
Okay. So if let's say some of you couldn't figure out how, then we might use the longest way. Maybe this one is the longest way. Okay, one ATM we know that is equivalent to 760 tall. Okay, so now I have no idea about what value of my ATM is, but I know the tall value is 740. So over here we can do a simple cross multiplication. Okay, so which represent like this. Maybe madam put an unknown over here. The value of unknown, let's just put an x. Ini macam simple mathematic lah. Okay, 760x. This one is for those who couldn't understand how to do conversion, yeah? Okay, so 1 times 740. So to find your value of x, you will see, okay, I will get the same pattern. Okay, 740 divided by 760. Okay, and try to calculate the values here. What is the value that you got? Madam pun kira juga ya. So berapa value yang awak dapat?
0.97.
0.974.
974. Okay, so you will see 97368 something something something, right? So it's better for you to take about 4 decimal places. Okay, so we will take the values 0.9737 ATM. Is that good? Is that okay? Boleh ke semua?
Boleh, madam.
Okay, madam keluarkan satu soalan lagi yang awak bagi tahu madam jawapan dia apa. Okay, sekarang madam ada 101 kilopascal. Tell me what is the value for ATM.
Zero point 9968.
Okay, 0.9968. Everyone's agree? Is everyone agree?
Yes.
Agree ya? Okay. So madam nak bagi tahu dekat sini walaupun 101 dia nampak lebih kurang macam 101.325, but you cannot round off. If you simply round off, you will get back 1 ATM, which is different from 0.9968. Therefore, we would get a more accurate pressure. It's important for you to take the decimal point. Don't round off straight away. Very important, yeah? So if for those who don't understand how to get this value, you simply get 101, divide by the original values over here, 101.325. Please check the unit also. Kilopascal, then we take the value for kilopascal. If let's say you see nm negative 2, then you will take the value for nn negative 2. Okay, so follow the unit. So in this case, we get back 0.9968 ATM. Ingat jangan round off terus jadi 1 ATM. The value will be very different. Okay. So is everyone good over here?
Good.
Okay. So madam nak bagi tahu kenapa kita belajar unit conversion sebab dalam PVNRT pressure will always be in ATM. That's why important for you to know that. Okay. And then the second one we have over here is our volume. Volume everyone should be very familiar. In liter, 1 liter equals to 1000 milliliter. Okay. There's some corrections over here. 1 liter equals to 1 dmq. It's not 1 dm negative 3. Yeah. So please do the corrections over here. 1 liter equals to 1 dmq. Similarly, 1000 milliliter is equals to 1000 cmq. This one is cmq. Sorry, madam, typing error. So do the correction. So if let's say PV and RT, if the gas constant just now we mentioned, right, ATM, liter per mole per Kelvin. Okay, if let's say we want to substitute the liter with dm cube, can, no problem. So ATM, dm cube per mole per Kelvin. Sama juga sebab liter sama dengan dm cube. Okay, faham ke sampai sini?
Madam.
Okay, so next one we will have over here is temperature. So madam nak awak potongkan dalam awak punya nota when it involve R. So madam sekarang tak nak hanya R saja, madam nak sentiasa. Okay, so temperature is always in Kelvin. So just now madam have already show you lah. You just take the temperature in degrees Celsius and then plus 273.15. Sometimes the questions will give you 273 Kelvin. No problem, you follow the questions. Okay, so we can use either one, 273 or 273.15. Dekat sini, kalau soalan sudah bagi, baik awak ikut soalan. Kalau tak ada, dua-dua ni boleh pakai. Okay, 273 or 273.15. Okay, and the next one, gas constant lah. Rearrange the units over here. Doesn't matter. You can start with liter ATM as long as you know which one is per or to the power of -1. It should be N and T. Okay, so per mole per Kelvin. Ataupun kita boleh tukar sequence dia. Per mole per Kelvin dulu, baru kita letak liter ATM. So the arrangement over here, no problem. Okay, last one is just a reminder lah, because madam know you are quite familiar with STP, RTP, isn't it? Tahu kan? Tapi mana nak tahu dalam nama panjang STP stand for what?
Standard temperature pressure.
Standard temperature and pressure.
Very good. Standard temperature and pressure. That means you must have got the temperature and the pressure. So in this case, if you see STP, that means it's happened at pressure equals to 1 atm. Temperature happens at 0 degrees Celsius. Okay, standard 0 degrees Celsius, I remember, it's not at 25. Okay, so if 1 mole of the gas, any kind of your gas, it can be a mixture, it can be oxygen, any kind. Okay, so it will occupy the volume, which is equals to 22.4 liter. Okay, 22.4 liter. So over here, if you look at the value over here, we got already N. 1 mole is your N. And then we have the volume, 22.4. We have the pressure, we have the temperature. So actually, you have already got the 4 variables here. Okay. Or in another one, we have our RTP. What does RTP stand for?
Room temperature.
Room temperature.
Okay, room temperature and pressure. Tapi biasanya dia tak bagi short form, dia tak bagi RTP. Dia akan bagi dalam ayat room temperature and pressure. So you must remember, pressure still 1 atm, but the temperature now, room temperature, we according 25. Bukan ikut suhu Malaysia tau. Temperature, room temperature, we follow 25 degrees Celsius. Okay, and then it's happened at 24.0 liter. Now that one stands for your volume. Okay, so daripada unit awak akan tahu, okay, value ini represent apa? If mole, it represent number of mole. Liter, it represent volume. ATM represent pressure. Then Kelvin or degree Celsius represent temperature. Okay, so this is our unit conversion and answer constant. So let's just start with our calculations part. Okay, those who have already done, no problem. You can check your answer. Those who haven't, we will calculate it together. Okay, so soalan ini, hold on ya. It's actually inside your file already. So if you look at your notes, madam have already given, right? It's actually underneath here. Cuma madam tak sparekan tempat kosong untuk awak. Awak kena keluarkan kertas dan jawablah soalan dekat situ. Okay. All right. So first questions. A sample of gas occupied 5.6 liter container. So this one stand for? What is the variable?
Volume.
Volume. So we write down first volume. Okay. At pressure 1140 millimeter mercury. And then this one stand for?
Pressure.
Pressure. Very good. So the gas is then compressed to 4.8 liter. So again, what is this variable?
Volume.
Volume. You had two volume, right? So we need to put down one or two. Okay, so this one is our V1, this one is our V2. So determine the new pressure, another pressure. So this one is our P2. So interpret the questions first. So determine the new pressure in ATM. This is the requirement of the questions, inside the container. So what formula should we use? So straight away
Boyle's
you
law.
can see it already. Boyle's law. Okay, so according to Boyle's law, we got P1, V1, P2, V2. Okay, but before we substitute the value into P1, V1, P2, V2, what should you do with the pressure?
Convert unit.
Convert into
ATM.
ATM. Okay, actually if the question doesn't request, kalau soalan tak minta dalam ATM, awak boleh teruskan jawapan dalam millimeter mercury, tak ada masalah. Okay, but in this case, the questions have already request ATM, then we might as well just change it before we do calculation. Okay, sebab bukan PVNRT, so dia punya pressure mana-mana satu unit boleh. Depends soalan. Okay, so kita cuba carikan pressure P1 kita. Okay, so 1140 millimeter mercury. What is the value in ATM? So we use 1140 divide by? And divide value berapa?
760.
Okay, and what value do you get? 1.5. Jangan lupa tulis unit. Okay, 1.5 ATM. So you just substitute the values only. 5.6 is your, a 1.5 is your first pressure, then times with 5.6. Then the second pressure is what we want to find, and you got the second value 4.8. So calculate for the new pressure over here. And see what values you have got here. Dapat value berapa? 1.75 ATM. Yang lain setuju tak?
Setuju.
Setuju. Okay, don't forget unit very important. Tak ada unit maksudnya jawapan salah. Okay, so the new pressure 1.75 ATM. So very straightforward lah for these questions. So we'll start for the easier one into the difficult one, yeah, step by step.
Madam,
Yes.
kalau kita tak tukar unit dulu, boleh ke?
Okay, kalau awak tak nak tukar unit dulu, so maksudnya awak akan buat macam ni. Okay, we use another one, yeah. If you don't want to change first before you do calculation, can, no problem. You put 1140, 5.6, then you got the new pressure, you got 4.8. So after you calculate, you get your answer into millimeter mercury, then only you convert into ATM. Also can. But important things sebab soalan minta kita dalam ATM. So awak nak tukar dulu baru apply formula, ataupun awak nak tukar kemudian pun boleh asalkan janji tukar. Okay?
Okay, madam.
You will still get back the same answer. Alright, so everyone's okay. Can I proceed second questions? Kalau madam terlalu cepat kena cakap tau, awak jangan malu. Apa ni, malu tanya sesat jalan something like that. I'm not sure lah. But it will be better for you to ask if you think I'm too fast or you can't understand, then you just ask. Kalau awak tak tanya, madam akan anggap awak okey je. Okay, so our second question is over here. So let's see what information we have got inside the questions, yeah? So a balloon is filled with 1.95 liter. What does it stand for?
Volume.
Volume.
Volume. Okay, so the second one, at 25 degrees Celsius, don't forget we must convert into Kelvin. Catat dulu awak punya key point. Temperature kena change into Kelvin. Okay, so it's placed in a car under the sun. So calculate the volume of balloon. So we have another volume. So we need to abbreviate. Kena tulis V1, V2. So when the temperature in the car reaches 90 degrees Celsius. Okay, another temperature is here. So what formulas do you want to use?
Charles law.
Charles' law. Okay, Charles' law. And then formula?
V1 T1 over V2 V2 T2.
Okay, so V1 over T1 equals to V2 over T2. So you can separately do the conversions of the temperature or you can straight away do it inside your formula. Okay, so volume yang pertama 1.95. Temperature yang pertama kita kira. Nah, terus kira pun boleh, tak ada masalah. So now madam is showing you how, yeah? Okay, so we want to calculate the V2. So the second temperature 90 plus 273.15. Okay, so tell me what is your second volume? So this is applying our Charles law, yeah? Is anyone?
Macam mana nak bezakan ni Charles Law, teacher?
Sorry?
Macam mana kita nak bezakan, kita nak tahu yang ni Charles Law ke, ni Boyce Law ke?
Yang ni kena hafal, Irfan. Formula dia. Kalau kita cakap boys, dia memang P1V1, P2V2 ikut dia punya definition.
Oh, okay,
Kalau
faham.
Charles, dia V1T1, V2T2. Kalau dia ialah Avogadros, kita ada V1N1, V2 N2. Tapi kalau ada P, ada pressure, ada volume, ada temperature, then kita guna combine. So kena pastikan soalan dia bagi information apa. Dia mesti akan ada clue. Semua clue, every tips and clues you will be able to find inside the questions. Okay?
Oh, just hafal formula dan masukkan cari, lepas tu tu je lah.
Yeah.
Okay, thank you.
So volume yang kedua dapat jawapan apa?
2.3751.
3741. Okay, so 38 liter. Liter normally we will do in if you want to give 2375 can, no problem. 38. Okay. And then next one we have our question 3. So is everyone want to ask any questions about question 1 and 2 before we proceed to question 3? Tak ada soalan ya? Tak ada, madam proceed ya. 3. Okay, question number 3. Tell me what information you have got. So sekarang interpret sendiri. What values have you got in the first sentence?
Volume.
Okay, you have got volume and
Pressure.
pressure. Pressure is already in ATM. No need you can nothing you can do. And then temperature, it should change into Kelvin. Okay, and then after that, what you want to find?
V2.
V2. Okay, so V2. So interpret dulu sebab ada dua volume, so kita put abbreviation first. Okay, so when this balloon is brought to the summit of Mount Hood with the atmospheric pressure 532 millimeter mercury. So we see the second pressure, isn't it? Millimeter mercury represent pressure. Jangan tanya, madam, macam mana tahu pressure? Kalau saya tak tulis benda ni, saya tak tulis atmospheric pressure, daripada unit awak kena faham. Millimeter mercury lah, Pascal lah, atau Newton per meter square. Semua ini adalah unit pressure. Okay. And then the temperature, last one is 0 degrees Celsius. So again, temperature change into Kelvin. So formula apa yang nak guna? Laws apa yang kita obey?
Combined gas law.
Combine gas law.
Combined gas law. Combined gas law. What is the formula? Later ya, madam pilih orang untuk jawab. Siapa ada dekat sini? Madam nak panggil orang yang tak pernah dengar suara. Siapa yang tak pernah? Marcella ada tak? Marcella. You have a very nice name, Marcella. Are you here?
Ada, madam.
Ya. So, formula apa yang awak pakai ya? Kalau combined gas law.
Gas law.
Combined gas law. Alvin dah bagi tahu clue dah. Combined gas law kita nak pakai. So, formula apa yang kita nak pakai?
NRT.
NRT, that one is idea. Kalau combine?
Salah
Salah Siapa nak tolong? Tengok siapa yang tak pernah
Teacher, kalau combine gas law ni maksudnya kalau kita kena guna Boyle's law dulu, lepas tu baru guna Charles law ke macam tu ke?
No. Madam tak ajar kan. Tak ajar formula untuk combine gas law apa dia kan. Siapa lagi? Hiran ada. Hiran Rao. I don't know how to pronounce your name. Hiran. Ada?
Yes, madam.
Yes. So what formula do you use?
P1 V1 over T1 equals to P2 V2 over T2.
Very good. Ayo, salah tulis. P1 V1 over T1, and then we have P2 V2 over T2. Okay, all this formula you must remember, yeah? We got the Avogadro's, Boyce-Charles combined and ideal gas law. So P1 V1 T1, P2 V2 T2, that one is combined gas law. Whereby we combine together Boyce and Charles. Bukan separately tau. Kena sekalikan. Okay, so now convert the pressure, convert the temperature, and then substitute inside the formula here. So we want to know what is the volume, your V2. Amanda nak tahu dululah awak punya pressure kedua. Your second pressure here, P2. 532 mm mercury sama dengan berapa ATM? Jangan jawab dulu, Madam pilih orang. Okay, who is our next? Ni Jamie. Jamie, are you here, Jamie? Nak pilih orang jawab baru akan alert kan? Jamie ada? Jamie, where are you? Tiba-tiba Madam panggil jatuh dari atas katil. Baru nak bangun. Tak ada, Jamie tak ada. Iliana nama apa? Iliana Farah. Iliana ada Iliana. Tak ada. Rui? Rui.
Yes,
Rui, are you
madam.
there? Okay, so tell me about the pressure that you have changed into ATM.
I got 0.7
0.7? Some more?
ATM.
0.7 ATM. Everyone's agree?
Yes.
Yes.
Okay, good. So 532 divided by 760 give you 0.7 atm. Okay, so temperature is still the same line. You plus 273.15. Okay. And your volume V2, dapat jawapan tak? Jawapan apa yang dapat?
20.47.
Yes, very good, Aina. 20.47 liter. Okay. So using combined gas law, this is how you're going to interpret the questions and how are you going to substitute the values. But make sure the units are the same. ATM match with ATM, and then Kelvin match with Kelvin, liter match with liter. Okay. Make sure you got the answer ya, 20.47. So siapa tanya? Atika tanya, Madam kalau dalam exam tak nampak. Kejap. How am I going to see the message? Okay, Atika tanya, Madam kalau dalam exam akan ada ke soalan yang kena state law apa yang kita guna? Maybe yes. Maybe dia akan tanya macam tu. In structures questions previously we have got this kind of questions. So they will first ask you to define what is gas law, and then after that, the questions. Sometimes yes, but I won't say 100% lah. But you need to prepare for that one. Oh, bagus Atika. You show a very good example. Kalau ada soalan, malu nak tanya, boleh type. Madam nampak, Madam dah jawab. Okay, so let us proceed to question 5. Madam left out question 4, yeah, but no problem. We're straight away into question 5. Okay. Oh, question 5 nampak sangat senang kan? Pendek. So let's see what is inside here. A steel tank has a volume of 438 liter. Okay, filled with 0.885 kilogram. Ini ialah apa? What is this stand for?
Mass.
Mass. Okay, kalau biasanya mass, kita boleh cari apa?
Mol.
Number of mole.
Yes, very good. Mass, we can find number of mole. As we know, mass divided by molar mass give you the number of mole. Okay, so oxygen gas, what is the formula of oxygen gas?
O2.
O ke O2? Oxygen gas. The natural oxygens that you find in the air is O2. So Madam want you to memorize. Semua orang boleh tulis, catat kan. Kalau nampak oxygen gas, it stand for O2. Nitrogen gas, kalau dia bagi perkataan, dia tak ada bagi simbol. So nitrogen gas, N2. Hydrogen gas, H2. How about fluorine? How about
Cl2.
fluorine? Fluorine, F.
F2.
2. Then group 17, Cl2, Br2, I2. So ketujuh species ini awak mesti kena ingat dia punya formula. Oh, it always come in the diatomic molecule. O2, N2, H2, F2, Cl2, Br2, I2. Okay. Kalau dia nak single, dia akan mention lah atom, oxygen atom. Tapi kalau dia mention oxygen gas, it will stand for O2. Okay, so the next questions over here, calculate the pressure of the oxygen gas at 21 degrees Celsius. Oh, dekat sini kita ada temperature. So, nampak tak dekat sini kita nak guna formula apa? What did you see?
Ideal gas equation.
Kenapa ideal gas?
Is given the mass, and we can find a mole.
Okay, and then we got 4 variables straight away. We got P, V, N, and T. Remember, constant R is a fixed value. So that once everyone should know lah. Okay, so in this case, we're using the ideal gas law, PV equals to nRT. Okay, so if you want to change the mass straight away into number of mole, can no problem. So we do on top over here, mass of oxygen. Mole of oxygen. Okay. So how are we going to calculate the mole? Is it using 0.885?
No. Convert
Why
to
not?
gram.
Why convert to gram? Because molar
Because
mass?
molar mass is gram per mole, no kilogram per mole.
Yes. Molar mass of oxygen, okay, is in gram per mole. Ingat molar mass adalah dalam gram per mole. So anyhow, you need to convert this kilogram into gram. So kita kira lah. Okay, masukkan formula dulu lah. So 885 gram, because 0.885 equals to 885 gram. Divide by, what is the molar mass of oxygen?
32.
32. 2 times 16. Because we have O2, you need to times 2. Okay, so over here we got 32. So gram over gram per mole. So over here you will get your answer in the units of mole. So try to calculate for this one. Let me know what's your answer, yeah? 27 point?
27.656.
Okay, 27.65. You want 656 can, you want 6563 also can, or you want to 65625 also can. Okay, so let's just put this one, 27.66. Okay, so apa lagi yang kita nak tukar?
Temperature.
Temperature. Okay, so try to calculate the pressure now. Pressure, number of mole, we got 27.66. Value of the gas constant, 0.08206. Unit tak payah masuk tak apa. Asalkan awak faham dan sudah tukar unit sebiji macam apa yang ada dalam PV&RT. Then in the calculation, you don't have to show. No problem. Okay, and then temperature, here we have 21 plus 273.15. And last one, we have our volume, which is 438 liter. So unit semua dah okay dah. Boleh terus kira. Tapi kena make sure lah, mole, and then temperature in Kelvin, volume in liter. So your final answer, pressure should be in ATM. Okay. Those who have, then this one, let me know about your answer so everyone can check it together. See whether we all got the same answer or not.
$1.5288.
Yes. How about the others? Are you agree? 1.52.
Yes.
Yes, madam.
Agree.
agree.
Okay. So far, can you follow? Is it okay? Senang.
Yeah, follow.
Yes,
Senang,
madam.
yeah? Okay. Right. So we get a little bit higher level. So next question, question number 7. Oh, nampaknya semua soalan dia pendek kan? Okay. But the important things, you know how to interpret the questions. So our question 6, nitrogen dioxide's formula is given NO2 is a reddish brown gas, which is a component of smoke. So calculate its density. Okay. At 0.950 atm, which is a pressure, and then you have a temperature 24 degree. So which formula are we going to use? Which formula are we going to use?
Density.
Density. Dapat hafal tak?
Pressure times molar mass over R over T. R times T.
Okay, pressure, molar mass, and then gas content, temperature. Madam, saya tak hafal lah. Saya tak tahu macam mana nak dapat. No problem. If you know about the step just now, we do the derivation, we rearrange the formulas, right? You rearrange back again. So madam, show you one more time, how to get the formulas over here. So since about we start with PV and RT. Okay, we know the number of mole equal to mass over molar mass. So we do the substitutions over here, PV. Okay, we got MRT over molar mass. Okay, so after you insert the number of mole formula into PV and RT, then the next one we want to substitute the density formula. Because we want the symbol D inside of formula. So in this case, we try to rearrange a little bit. We change the position between the volume and the molar mass. Then here you go. You will see the M over V, which is similar with the density formula. So after you have got until here, then we can substitute the symbol D inside your formula. So make D your subject. So similar like just now lah. How do you get this formula here? So the substitution, the derivation, actually you can do it straight away. So if let's say you don't want to memorize, that's okay. Madam banyak sangat formula nak hafal, tak apa, awak derive sendiri pun boleh. Okay. So, masukkan awak punya data yang ada. Pressure dah ada, temperature dah ada, constant ada, molar mass awak kena kira sendiri. Sebab tu dia bagi formula. So, what is the molecular mass for NO2? So, we have the
46.
atomic 40? 6.
46.
So kepada sesiapa yang tak tahu macam mana nak kira molecular mass, you have to practice ya. Atomic mass untuk nitrogen 14. Untuk oksigen 16. So 2 kali 16 and here give you 46 gram per mole. Okay, and then after you got the molar mass, you just substitute into the formula of density. Pressure 0.950, molar mass 46. Divide by the gas constant 0.08206. Then temperature, you need to plus with 273.15. Okay. And then I give you the final answer for checking. It should be equals to 1.79 gram per liter. Okay. Madam think the unit of density is come from your calculation. So if let's say you have no idea, madam saya tak tahu macam mana nak dapat gram per liter, then you have to show the unit in your calculation. So pressure over here, madam tak tulis nombor madam cuma tunjukkan apa dia punya unit saja. Okay, so pressure in ATM. Then the molar mass we have in gram per mole. Okay, and then gas constant, if you still remember, we got ATM, liter per mole per Kelvin. Temperature awak sudah tukar dalam Kelvin kan, so dia ada unit Kelvin. Dekat sini ada value awak lah. So how are you going to get your unit? You simply cancel off the similar unit over here. So ATM, we can cancel. Okay, and then per mole and per mole we can cancel. Per Kelvin, per Kelvin and Kelvin can cancel because they are at the same row. Up and down it need to be same. Same row, one negative, one positive. So cancel off. Okay, so what is left over here? We got the gram per liter. Okay, because when you bring out your liter, it will become liter. It will become liter to the power of -1. Okay, sampai sini boleh ya ikut?
Boleh ikut.
Dapat dah jawapan 1.79? Ada jawapan lain?
Tak ada.
Sama ya? Okay. Alright, so we proceed to our next questions. You ready?
Ready?
Yes.
Okay. Oh, lagi simple satu ayat. Stop. Okay. A sample of CF2Cl2 occupied 25.5 liter. So volume liter. Okay, and then 298 Kelvin, yang ini ialah apa? 298 Kelvin. Temperature, do I need to convert?
No.
No need.
No need, right? It's already in Kelvin, so that means it's already good for you to do calculation. And then the next one, kilopascal, what does this stand for?
Pressure.
Pressure. Okay, and then we need to convert into
ATM.
ATM. And we try to calculate it first. So what is the pressure here? 15. Okay, the pressure equals to 153.3 kilopascal. So what is it in ATM? We see first what is the value. So using 153.3, you divide by 101.325 because it's kilopascal. So boleh rujuk balik chart yang Meda bagi. So what value do you got here? What value do you get for ATM? For 153.3 kilopascal.
1.51.
1.513.
Okay, so value you got 1.512953368. It's very wrong, right? So if let's say you take 4 decimal place, you will be round off because after 9 is 5. So semua orang tengok pada awak punya calculator. Tak nampak kot madam punya. Okay, so akan check lah. 5129. If 4 decimal place, you will going to round off into 513. Okay, so dekat sini adalah kita punya pressure. So we have got the volume, temperature, pressure. So what happens to the question? Soalan minta volume sekali lagi. Kan depan ada volume, belakang pun dia minta volume. So apa yang kita nak buat dekat sini? What do you need to do? STP. What does STP stand for? What is the pressure at STP? Temperature?
1.
Volume. What is the
1
pressure?
ATM.
1 atm. The temperature?
0 degrees Celsius.
Yang lain pun ikut juga tulis STP. It happens at the pressure 1 atm, temperature 0 degrees Celsius, and then number of mole we have no idea, but we have to find the volume. So maksudnya dekat sini for your first sentence we have to find number of mole. If you see VTP, apa yang hilang dekat sini adalah number of mole is missing. So you have to use the PVNRT to find the N for the first sentence here. Okay, so let's just calculate for the number of mole of our CF2, Cl2 before we calculate for the second part. Okay, so PV, NRT. Kira dulu untuk number of mole CF2, Cl2. Ini untuk first part ya. So you substitute inside 1.513. You substitute the volume 25.5. And then number of moles is what we want to find. Gas constant we have got 0.08206. Temperature 298 is already given. So find the number of mole for our CF2, Cl2. Ini bagi masa sikit Lepas soalan 8 nanti kita akan ada satu break. So we finish until question 8. We have a 5 minutes break and then after that we will come back to another subtopic. Okay. Meda select person untuk jawab ya. Get ready everyone. Can I see Syamimi? Syamimi ada? Nurul
Yes, ada.
Syamimi. Syamimi dah siap jawab ke?
Well, I get 159.8581.
100 something ah. Hmm? 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 Kejap ya. Number of mole untuk CF2, CL2 dapat 1. Kejap ya, Madam Salim dulu jawab punya jawapan. 1.
59
Mhm.
point 8581.
It's quite far away. Ada tak Syamimi bila calculation sama macam Madam dekat sini?
Oh, wait, madam. I salah. Salah ganti.
Salah ganti. Cuba kira balik. Okay, Madam select another person.
Teacher.
Ya, siapa?
Yang atmosphere tu, ATM yang kita tukar KPE pergi ATM tu, boleh kalau macam ni saya dapat 1.58.
Macam mana?
1.518.
518.
Boleh.
Irfan macam mana kira?
Saya buat 153.3 bahagi dengan 101.
Point?
Oh tak, saya tak ambil point.
Itulah Irfan. Madam baru cakap tak boleh macam alah dia 101.325. Saya boleh simply round off, cannot. Untuk pressure dia sensitif. So kita memang kena ambil tepat-tepat 101.325.
Okay, thank you, Cik.
If you get exactly the same, you'll get the same value as Madam. Okay. Can I see where is Fatin? Ada banyak Fatin dekat sini. Fatin. The first Fatin I see. Fatin Syahinda. Betul tak Madam mention nama awak? Nur Fatin Syahinda. Betul tak? Ada tak Fatin? Fatin, where are you? Tidak. Ashikin, Nurul Ashikin.
Yes, madam.
You dapat jawapan apa?
1.58 mol.
1.58. Okay, very good. Or maybe 1578. 1578 can 1.578 or 1.58. Both accepted, yeah? Okay. So after you have found your number of mole, so that means over here we have got the value 1.58 mole of CF2Cl2. So for the following data here, you have two options. Satu option yang sebelum ini awak pernah pakai, which is using volume of CF2Cl2 equals to number of mole times with the molar volume. Okay, macam mana kita cakap molar volume? So, if it's at STP, okay, so 1 mole of the gas occupied 22.4 liter per mole. Ini adalah kita punya molar volume. So, this is what you have used before. So, using 1.58 times 22.4 and you will get your answer. This is the first method that everyone should be able to calculate. The method similar like the one you learned before. And in this case, you get 35.39 or maybe 35.4. Kalau dia 9 round off, tak ada masalah lah. 35.39 or 35.4. Okay. Ini adalah salah satu method. Method yang kedua, boleh je kita pakai PVNRT for the second time. So pressure is 180 m, volume is what we want to find. Number of mole 1.58, then gas constant, and then temperature is 0 plus 273.15. Okay, so ada cara yang pertama, ada cara yang kedua. So dua-dua boleh pakai lah dekat sini. Okay, so if you see some questions like this, some information is missing. That means you have to separate both calculation into two parts. Calculate dulu number of mole in the first part, and then calculate for the volume for the second part. Okay, because the condition is different. Condition yang pertama, temperature pressure dia lain. Condition yang kedua berlaku pada STP. So separate kan.
Madam,
Yes.
macam mana guna PV and RT yang kedua Mim kata tadi?
Substitute saja value awak. Okay. Jawapan dia lebih kurang sama. So let's say 1 atm over here, then volume is what we want to find, isn't it? So 1.58. Okay. Lepas tu masukkan awak punya gas constant. Masukkan temperature dalam apa ni Kelvin, which is 273.15. Cari pula awak punya volume. Is that okay?
Madam.
Sama je dia punya working step PV and RT.
Madam,
Yes.
for this question, can we use for the combined gas law? Because I get for the almost the same answer for the one answer.
If you want to get combined gas law, can, no problem. Because the number of mole is the same for both. So for number of mole, you can cancel off. So you can use combined gas law as well. Okay, so that means you use the PVT for the first set and then PVT for another set. So find the second volume. No problem.
Okay, madam.
Okay. So madam catat dekat sini. One of the method over here. Okay, second method. Maybe you can use the combined gas law. All right. Okay. Dah siap ke? Dah siap salin? Siap checking?
Dah Madam.
Okay, madam teruskan last question 8 and after that we will rest for 5 minutes. Okay, so last questions over here. Ooh. Our last question is slightly difficult. Let me check. Where's my last questions? Okay, so if you look at question 8 over here, in the question says that in a chemical reaction, okay, hot hydrogen gas reduce copper 2 oxides to form pure metal and H2O gas. So dekat sini dia bagi dalam satu ayat. Boleh tak Meda tahu hydrogen gas formula dia apa?
H2.
H2.
H2, very good. And how about copper 2 oxide? Where's the formula?
CuO.
CuO.
CuO, very good. Because copper we have two oxidation. This one is referred to the oxidation state, Cu2 plus. So when combining with oxygen, you get CuO. Okay, so the pure metal here, because H2CuO, pure metal is your copper. Okay, and then H2O gas. So on a laboratory scales, what volume of the hydrogen gas is needed? So we want a volume. Okay, to reduce 35.5 mass of copper 2 oxide. So this one is the mass and we can find the number of mole. Boleh catat lah mass. Kalau dia bagi mass, kita boleh cari number of mole. So the pressure given over here is in unit torr, and the temperature also we need to convert the unit. Okay, so for this question, first of all, you need to look at the overall balance equation. Kena keluarkan equation sebab dia adalah salah satu reaction. Okay, it's one of the reaction. So let's see. Copper oxide, solid. Okay, we got hydrogen gas. Okay, starting from this chapter, you need to be able to write out the phase. Yeah, copper oxide solid, hydrogen gas, and then you're producing your copper metal, and then H2O is a vapor, is a gas. Is this equation's balanced?
Yes, madam.
Yes.
A balance can. Okay. So what informations we have got over here, we extract, we bring down into your equation. We got 35.5 gram of copper two oxide. Okay, so in this case, we know what is the number of mole of copper oxide, isn't it? We try to calculate straight away. What is the molar mass of copper oxide? Any idea?
79.6.
Okay, 79.6 because the copper, what is the atomic mass of copper? We got 60,
63.6.
63.6. So sometimes the questions will give you 63.54. Okay, so either one you want to use 63.54 or 63.6. So plus with oxygen 16 give you 79.6. So the number of mole over here we have got 0.44.
646.
446 mole. Okay, 0.446 mole. Okay, so is what we want. Is this number of mole is what we want? Okay, kita patah balik kepada soalan. What volume of hydrogen gas is needed? Okay, at 76225 degrees Celsius. So kalau awak nak kira volume hydrogen gas, awak perlukan mole untuk siapa?
Hydrogen gas.
Hydrogen gas. Okay, remember this is the volume for the copper oxide. So we have to find the mole for our hydrogen gas. But you're lucky these questions they have the same ratio. Sebab kenapa kita kena keluarkan equation? Dan kena pastikan equation dia adalah balance. Okay, so CuO, H2 they are same mole ratio. Therefore, the number of mole of our hydrogen gas equals to the number of mole of copper oxide, which is the same value as 0.446 mole. Okay, yang paling senang awak tulis macam ni. Kalau tak nak, kita boleh apply kan awak punya stoichiometry daripada chapter 1. So say 1 mole of copper oxide equivalent to 1 mole of hydrogen gas. So if we got 0.446 mole of copper oxide, therefore the same number of mole for hydrogen gas. Do you get this one? So kita apply balik stoichiometry daripada chapter 1. Is everyone okay? Yes, no, yes, no. Good, no? Okay. So lepas sudah dapat
Yes.
mole untuk hydrogen gas, then you can apply your PV and RT. You get the pressure, but you need to change. You need to find volume. Now you have got the number of mole. You have the temperature, but convert the unit lah. So jangan lupa unit penting. So either you want to do it separately lah. If you scared you forgot. So pressure kalau 765 tol sama dengan berapa ATM. Ingat tak boleh round off So what is the values? It must be different from 1 ATM. So what is the value?
1.0067.
1.0066.
66, 1.007, both are okay. Dua-dua boleh accept. Tapi dia mesti beza daripada satu ATM. That is the only difference. Then you have to show it. Otherwise, why not I just put 760? So there must be a difference in your pressure. Okay, so dekat sini temperature pun kita tukar teruslah 225 degree Celsius sama dengan berapa Kelvin? Empat?
49 and 0.15.
Okay, very good. So now we apply into PV and RT. Pressure, volume, number of mole for hydrogen gas, and then RT. Okay, yang ini H2 adalah abbreviation sebab dekat sini saya ada banyak species. Saya ada copper oxide, saya ada hydrogen, saya ada copper, saya ada H2O. So I need to put this abbreviation. Dia punya simbol. So maksudnya number of mole ini belong kepada siapa? So awak kena tulislah sebab the next subtopic, this abbreviation very important. Okay, so try to calculate for this volume of hydrogen, and you should be able to get, what is my answer? 18.1. Okay, you try to check whether you got this value same as madam, otherwise madam need to recheck back. Okay, madam check a little bit. There is a slight difference, 1.11. Did everyone get this the same?
Yes.
Okay. So are you happy until question number 8, the examples given here?
Yes, madam.
Boleh ya?
Yes.
Okay. So madam bagi kerja dulu untuk subtopik ini sebelum kita masuk Dalton's Law. Okay. So madam tak nak bagi kerja banyak lah. Nanti you complain banyak, madam takut. Tapi sebenarnya buat lagi banyak lagi bagus But don't worry, all the answer will be uploaded into your Google Drive. After you submitting, only madam will upload. So if can try to finish all these questions. But madam only want you to show me 2 of this into GC. Okay? Tapi bukan maksudnya yang lain tak payah buat. Awak faham tapi boleh apply ataupun tidak awak punya konsep. Lain cerita. To see whether you have got it, you have understand the topic, you have understand the calculations technique, then you have to try. Okay? So madam give you 5 minutes break, and then after that we will come back for the second subtopic, yeah? 5 minutes. So now is 9:17. I'll come back at 9:25 like that lah. 25 now, 23. Okay? Siapa nak pergi tandas pergi dulu. Nak tanya soalan pun boleh madam ada dekat sini.
Madam.
Yep.
Nak tengok slide tadi boleh?
Nak tengok apa?
Slide tadi.
Slide tadi. Ya. Question 8 ya.
Ya.